Hello and welcome back. Today we're going to be solving the fourth problem on NeetCode's 150 group anagrams. So given an array of strings, we need to group all anagrams together into sublists. So we would be returning a 2D list. You may return the output in any order. That's extremely helpful as the order, if the order mattered, we'd have to handle that in a separate way. So that's good to know. And just as a reminder, an anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Um, okay, yep. So let's go ahead and take a look at the first example here. We're given a list of 6 strings. Appears hat is by itself. I guess it doesn't have another anagram or another word that is an anagram to it. Here we have act and cat. That makes sense. If we were to switch C and A, that would spell cat. Here we have stop and pots, which is the reversed version of stop. And then lastly, we have tops. If we were to move S to the first position, that would spell stop. So that makes sense. So here we would return a 2D list, or rather a list of group of anagrams, or a group of anagrams, I guess for short. Then we're given another list of just X, and simply put, we group X by itself and we'd return a 2D list of just X. And then lastly, we're given a list of strings with just an empty string, and we would return that there. All right, that kind of makes sense. So let's go ahead and think through this a little bit more. Oh, I also like to mention that let's go ahead and identify a couple of constraints here. We could assume that if we're given a string, it'll be 1 or greater. I guess an empty string counts as 1. Yeah, I guess it counts as 1. I'm not sure. I need to double check on that. And then we're given, what's it called? Oh, no. This is our list, or the length of our list. So we will always be given at least an empty string, or just a string, I guess is the term. So the list cannot be empty. And then the length of a string could be 0. So yeah, this would be 0 or up to 100, and it's made up of all lowercase letters. So given this, the real cases we have to solve are actually kind of defined for us, right? We're given a case of having a list of strings. We're given the case of a single string. We're given the case of an empty string. But we don't have to consider an empty list. Not considered. Yeah, so 1 string. Yeah, so these are our main use cases, which is really well defined there. So are there any other cases we would want to handle? I guess if this wasn't, we'd have to consider it, but at this point in time, it's out of scope of this problem. Yeah, usually I look for empties, singles, multiple, anything else that we need to consider when working with a list. Of course, in Python, it's not enforced that we would know that it is of type string. And so if we wanted to, we could sanitize. But again, that would just make our code a little bit more complicated, but it would be a little bit more robust. It is something to consider, but for the scope of the problem, let's go ahead and disregard it. What else is there? Yeah, so I think this problem is pretty straightforward. Let's go ahead and talk about a couple of solutions. I think the first solution that comes into mind is probably sorting, which we used in our other anagram problem. And so the train of thought here is, like, let's say that we were to take take act and cat, we could reorder them to be act and act, and then we would then return true, or we would then group them. Sorry, we would then group them. And then let's say we did stops, pots, and tops. If we were to reorganize, oh wow, my alphabetical skills are terrible right now. Let's just assume stop is what it looks like alphabetically. Stop, stop. We would group them. Yeah, and so sorting, we would still need a way to maintain a list of, or maintain the groups that we have. So we could use a hash map, to contain it. So it would look something like this. We'd have act as act and cat, and then stop as stop, pots, and tops. And then simply put, we would then loop through our dictionary and get all the lists and then output it to another list. So what this would look like is we would first initialize a dictionary to contain anagrams, and then we would loop through our list. 3, we would sort the word and insert into dictionary, and then we would lastly have to iterate through dictionary values and append to output. Okay, let's kind of see how this performs. So in terms of time, right, initializing a dictionary, that's O1, loop through our list, that's O of n, and then we would need to sort every word. So let's assume that the average length of a word is m. Sorting would be m log m. And then iterate through the dictionary values and append to output. So we'd iterate through the dictionary values. What does this look like? So that would just be worst case m, so that would get reduced. So m, that would be like plus m, which ends up just being m log m because it's worse. And then if we were to combine this, we did n plus m log m, and then our space, we're using a dictionary, loop through a list. I guess that would be the size of the list, right? Because at most we would only store the amount of words in there. Okay, so that's O of n. Is there any other way for us to optimize this? So we know that the big bottleneck here is actually sorting the word. Do we have to sort it, or do we have to sort it? We do know that there is a finite amount of characters that we have to work with. And because of that, we know that it's all made up of lowercase letters. We could reduce this. We could ultimately reduce this to O of m by not having to sort. If we know that there's only a finite amount of characters, we can then start leveraging hashing. So here, we would still initialize a dictionary to contain our anagrams, we would still loop through our list, but instead of sorting, we could iterate through word, and keep count. And how would we keep count? We could keep count through like a list of 26. A list which should look something like this. 0 times 26. And this would allow us to create a unique key towards the end. Okay. And then 4, we would still iterate through dictionary values and append to output. So our time here can then get reduced to, so we have loop through our list, and then loop through our word plus m, which is just 2m, which gets reduced to n. So here we could reduce our time to O(n plus m). What about space? So space is still the amount of words in our list. O of n. So we still have to go through every word. Is there another way? Can we optimize this even further? We still have to scan through our entire list, right? So that's at least O of n. And we still have to scan through our words to know what letters there are, which is m. So I'm inclined to think that this is the most optimal solution. Again, if there is a better way to do it, please let me know in the comments down below. I can't think of anything better. So let's go ahead and deal with this. Group anagrams equals dictionary. So we have our group of anagrams. We need to loop through our list. So for word in strings. So for word in strings, we'll have this. Iterate through the word and keep count. So we'll have a count equals 0 times 26. Iterate through the word and keep count. So for letter in word, for the letter in our word, we would need to append. We would need to be able to iterate it to know our count. So here, the index 0 would be representative of A, and the good thing in Python, there's an order function for us to get the actual value of a letter. So order letter minus order of our lowercase a plus equals 1. So we can use a default dict here and set it to integer, so it'll set it to 0. Wait, no, that doesn't make sense. We would have a dictionary here, count 0 times 26. That was the wrong way of thinking about it. So we have 4 letter in a word. This should get us, that should get us how much words there are there. And what would we need to do now? So now we have our count, which we can't store as a key because it is mutable. We need an immutable one. So we can essentially set it as a tuple, right? So we'll call it key. I'm trying to think about this. Key, current key equals tuple count, so we could go ahead and cast it there. And we need to be able to store it to here, which is just a list. Yeah, okay, that makes sense. So we could go ahead and do that, set our default dict to a list. And then we would go into group of anagrams at our current key dot append is the function to add to a list, and we would add our word. Yes, and then we need to go ahead and create an output list, which is equals a list, and then for key comma value in, I believe it's group, you take your default dict and do items here, we would then do output dot append value and return output here. So here, let's run through it. We initialized our dictionary, we looped through our lists. So we looped through our list of words, and for every word, we counted the characters that they have, and we hashed it into count here. Then we converted it to a tuple, so we could set it as a key, as the key in our group of anagrams. This is basically our way of identifying which words have the same amount of letters, and then we went ahead and appended the word to our group of anagrams, okay, for that current key. Then we created an output list, and we iterated through our values, our key value in group of anagrams.items, and then we appended every list into our value here. So let's run through example 2. So strings x, so group of anagrams, word and strings count 0 times 26. So 4-letter in words, this should be like third from last or something. And it'll raise it, so then you'll have like, yeah, basically you'll have a 1 at like the 23rd position. We would then create a tuple so that we could store it as a key, and then we would append that to, we would append x to our dictionary. We would then create an output list, and we would iterate through our dictionary and output any values, and there should be x somewhere in there, or a list of just x, and we would append that into it and then return our output. Let's go ahead and run it. Okay, it looks like it's not working. A group of anagram is not defined. Yeah. And that for key and value, okay. Let's go ahead and run it. Sweet, we went ahead and passed our test cases here, and let's go ahead and run it here. Awesome, all right, looks like we did it. See you in the next one.